scholars, it's Miss Marnon. So it looks like you need some help with some compound probabilities and tree diagrams. So some vocabulary. First, we have a compound event. Is when you have multiple parts to the event. So that means there's multiple things happening. Compound events can be organized in stages. So one way to organize them into stages is using a tree diagram. So if Ion, Ladon, and Najmo meet to play games for a third week, they played it in an earlier lesson. Use a tree diagram to calculate the probability that Najmo wins exactly 2 times in the 3 weeks of games. So here we have the first week winner. We have Ion, Ladon, Najmo. If we have Ion win twice, then we could have Ion or Ladon, then we could have Ion and Najmo. So what we're doing is we're going to try to list every single possibility. So we have our 3 girls playing. So if Ion wins the first one, any of the 3 could win the second. Or if Ladon wins the first one, any of the 3 could win the second. Or if Najmo wins the first one, any of the 3 could win the second. Now going into the third week, let's switch colors here. Ion could win twice, and she could win a third time. Or it could be Ladon, or it could be Najmo. It could be Ion, Ladon, it could be Ion again. Ladon, or Najmo. So what we're doing is we're just listing all of the possibilities for each week, each category. And so we can keep going and making this. It's going to take a minute, but our main goal in a tree diagram is to list every single possibility, and it's kind of an organized way that we can do it. And then we can look at the path and determine all the different ones. So just going to keep going. Ion, Ladon, Najmo for all of these. Ion, Ladon, Najmo. So all of these are equally likely events in this, right? The girls are all playing the same. They all have the same chance of winning. There isn't really anything that's going to change. So now every single possibility. I actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I just have so many possibilities here, right? So we see it goes from 3 to 9. This whole row, there are 27 possibilities. So you can follow each of these. Let's get a highlighter out. It's like I can follow this from Ladon to Ion to Najmo over here. I can do Ladon, Ladon, Ladon. There's so many different ways to do this. So let's get a dark blue. We want the probability that Najmo wins exactly twice. Well, if Ion wins twice, that's not going to work. Ion, Ladon, no. Ion, Najmo, Najmo, there's 1. So I'm going to write it like that. Ladon, Ion, nope, that's not going to work. We need Najmo twice. Ladon, Ladon, nope. Ladon, Najmo, Najmo. And then that's the only one that's going to work. If we do Najmo, Ion, Najmo, that one will work. Najmo, Ion, nope, let's be that one. Najmo, Ladon, Najmo. And then, yeah, a bunch of Najmo, Najmo, Ion, Najmo, Najmo, Ladon. We can't do 3 times, exactly 2 times. Okay, so we have 1, 2, 3, 4, 5, 6 possibilities out of the 27 total. So you can simplify this fraction to be 2 out of 9. And then we can write that as a decimal, 0.2 repeating or 22.2 repeating %. So that's kind of how we work with tree diagrams. List every single possibility, find the possibilities that meet the criteria, and then write it as a fraction. And then from the fraction, you can do a decimal and %.